Problem 8. Justin wants to put 2 balls with radius 5 in a circular cylinder with radius 8. What is the minimum height of the cylinder? So this is a diagram of the cross-section of the 2 balls and a cylinder. Okay, so we have radius 5. Okay, so here, this one, this is 5. This is 5. And radius 5, radius 5. And we also have a circular cylinder with radius 8. So that means this is diameter with circular cylinder base. So it's 8 times 2 equals 16. So then we look at this right triangle. So we have hypotenuse, which is 5 plus 5 is a 10. And then we have this leg, which is 16 minus 2, 5. Okay, 5 times 2 is 6. Okay, so we have 6. Okay, so in this right triangle, this is 10, 6. So we know then that leg would be 8. So the height for this 2 balls put into a cylinder, minimum height would be 5 plus 8 plus 5. It is 18, which is B. Okay, which is B. Problem 9. In a chess tournament, Ada and Betty played the 3 rounds to determine the winner. For each round, the winner gets 2 points. The loser gets 0 points. If it is a tie, both players get 1 point. So then after 3 rounds, the highest scored player wins. If these 3 results appear equally likely between Ada and Betty, so what is the probability that Ada is a winner? Okay, so let's set win as W, okay, lose as L, and tie as T. So the case 1, so Ada could win 3 rounds because these 3 results are equally likely between Ada and Betty. So for Ada to win, so the probability is 1 over 3. So times 1 over 3 times 1 over 3. So this probability is 1 over 27. So case 2, Ada could win 2 rounds and lose 1. So because you have 3 different combinations of this, so you have win, lose, win, and lose, win, win. So even for the probability for win and lose is all 1 over 3 times 1 over 3 times 1 over 3. And you have 3 combinations, you multiple 3. So the probability is 3 over 27. So case 3, so Ada could just win 2 rounds and tie 1. So this is exactly the same as this one. So you have 1 over 3, 1 over 3 multiplied by 1 over 3, then times 3 is 3 over 27. So case 3. Case 4. So Ada could win 1 round and tie the other round, the other 2 rounds. So would it be also 3 combinations. So 1 over 3 times 1 over 3 times 1 over 3 times 3 is 3 over 27. So you add these 4 probability, which is 1 over 27 plus 3 over 27 times 3, right? You have 3 over 27, so it's a 10 over 27. So the answer is C. Problem 10. Let A, B, C, D, E, F be the vertices of a regular hexagon. How many distinct equilateral triangles in the plane of the hexagon have at least 2 vertices from A, B, C, D, E, F. Okay. So first, let's just use 2 adjacent points to construct equilateral triangles. Okay, so we will have, okay, so 6 equilateral triangles already. Okay, so we also can construct triangles like this, and 1, 2, okay. Okay, so just triangles like this, okay. Okay. The total is actually 12, right? So we have 12 equilateral triangles here, okay. So the next step, we will use vertices, like we connect vertices like AC, BF, and FD. Okay, the BD, AE, and EC. So here, see, these 3 vertices and construct equilateral triangles already. So at least 2 vertices. So 3 vertices also included. So we have 2. We have two more equilateral triangles. And we also can construct the triangles, use AC, okay, like this one, okay. So use AE, okay, like this, and use EC, okay, and FB, FD, and BD. Sorry, this one, it's, okay. So, BD. Okay, so how many triangles, more triangles we have now? So it's a 6, right? 6 side and construct 6 equilateral triangles. So we plus 6. Okay, so we erase all these triangles. So the last case is we connect the diagonal AD, BE, and FC. So as we know already, so each side we can actually construct 2 equilateral triangles like this. Okay. Okay, like this. Okay, so this one is also 1. And FC can give us 2. And BE can also give us 2. Okay, so the BE. Okay, so how many triangles? Equilateral, the size like this, okay. The blue one, okay. That size. Okay, so how many? So it's 6. Okay, 1, 2, 3, 4, 1, 2, 1, 2, 3, 4, 5, 6. Okay, so we plus 6 again. So total would be 26. Okay, so it's a C. 26. Problem 11. One student forgot to write the multiplication sign between two digits x, y, and got a two-digit number xy. This two-digit number xy is exactly 3 times the product of the original two digits x times y. So how many such pairs xy are possible? Okay, so we have two digits number xy. We can write as 10x plus y. So we can set the equation 10x plus y should be equal to the 3x times y. Okay, so let's solve for x in terms of y. It is y over 3y minus 10. Okay, so because the xy are all the digits, so the digits 0 to 9, but the 0 obviously is not the solution. So the xy actually, the digits is from 1 to 9 and 1 to 9. Okay, so then also means 3y minus 10 should be greater than equal to 0. So we solve that. So y should be greater than equal to 0 over 3. So then the possible digits for the y are 4, 5, 6, 7, 8, and 9. And x also equals to the y over 3y minus 10. So let's just plug in these numbers. Okay, so y equals 4. And we solve for x equals 2. Okay, this works. Y equals 5. And x equals 1 also works. And y equals 6. And x equals 6 over 8. Okay, it's the fraction, not the integer. And y equals 7. So x equals 7 over 11. Okay, so also not the integer. So y equals 8. So x equals 8 over 14. Okay, doesn't work. Y equals 9, x equals 9 over 17. Okay, so then we just have the two pairs of x, y works. So the solution is C. Problem 12, Jerry's farm produces 20 watermelons this year with the average weight of 20 pounds. The average weight of watermelons weighing more than 20 pounds is 27 pounds. The average weight of watermelons weighing less than 20 pounds is 18 pounds. At least how many watermelons weigh exactly 20 pounds? Okay, so we got 20 watermelon. So let's split into 3 groups. So less than 20 pounds, equal 20 pounds, and greater than 20 pounds. So let's set a variable. So number of watermelon in this group is x, y, z. Okay, number of melon. So then we have the first equation is x plus y plus z equals 20. And we also can set up the second equation is x times 18. Okay, 18x plus 20y plus 27z equals 20 times 20. Okay, so then we try to eliminate one variable. Let's just eliminate z. So we need to know at least how many watermelons weigh exactly 20 pounds. So we need to keep y. So z equals 20, 20 minus x minus y. So 18x plus 20y equals 27z. Okay, so 27 times 20, 20 minus x minus y equals 20, 20 times 20. So let's just combine the like terms of this equation. So finally, we will get 9x, okay, so 9x plus 7y. 7y equals 20, 20 times 7. Okay, so because we can factor the factor 7 from this term and 20, 20 times 7, that term. So let's just put this equation as this format. So 7, 20, 20 minus y. So as you see, so here has a 9 factor. So for this term, we only have 7 factor here. So then 9 factor has to be from 20, 20 minus y. So that means 20, 20 minus y has to be divisible by 9. Okay, so is divisible. Okay, so then let's try to divide it 20, 20 by 9. Okay, the remainder is 4. Okay, so that means 20, 20, if y equals 4, so minus 4, y equals 4, the smallest number of the y. So we can have 20, 16, so we can be divisible by 9. So at least 4 watermelons weighs exactly 20 pounds. The answer is B. Problem 13. The following graph shows the score distribution for a few games played by several basketball players. Which statement gives the correct description considering the mode, median, and the mean? Okay, so we can get the mode first. So mode equals to 5. So let's quickly calculate the median. So the median, so we need to count how many players total. Okay, so this is 1 player, 2 player, 2 player, 3, 2, 4, 2, 3, 1. So total added together is 20 players. Okay, so 20 players. So the median should be the score from number 10 and the number 11 players, the mean of that. Okay, so number 10 is 4, plus number 11 is 5. Divided by 2 is 4.5. So the median, we have median equals 4.5. Okay. Okay, so let's quickly calculate for mean. So 0 times 1 is 0, 1 times 2 is 2, 2 times 2 is 4, and 3 times 3, 9, 4 times 2, 8, 5 times 4, 20, and 6 times 2, 12, 7 times 3, 21, 8 times 1, 8. Okay, so let's add all these numbers. So this could be 20, 20, 40, 20, 20, 40, 40, 70, 70, 80, 84. Okay, so mean equals 84 divided by 20. So mean equals 4.2. So then we got it. It is mean 4.2 less than median, 4.5 less than mode. The answer is E. Problem 14. P is a point chosen randomly within the rectangle ABCD with AB equals 2AD. What is the probability that angle APB is obtuse? So angle APB and AB equals 2AD. So let's set AD x. So AB equals 2x. So I draw a semicircle with AB as diameter. Okay, so see if any point, if we P, if on this semicircle, so we know it will be right angle. Okay, so this is right angle, and that is also right angle. Okay, so any point inside of this semicircle would be obtuse, and any point outside of the semicircle would be acute angle. So then the probability for APB is obtuse if we randomly choosing a point would be area of semicircle over total area. Total area. Okay, so we know that for the semicircle, the radius is x. So 1/2 pi x squared over x times 2x. So then we cancel out x squared with this x and the times x. So finally it's pi over 4. So the solution, the answer is B.